Welcome to the 8th episode of the KTQA Studio Build-Out. I continue to be Sam. That has yet to change. And this is a pretty momentous episode. This one was a big one for me. So we've got sort of the furniture the way we need it. We've looked at the microphone processors, which are a major component of this studio. We've cleaned up the board, although you haven't seen that, and boy howdy did it need it. But we haven't actually operated the board or done much in the way of getting the board ready for operation until this episode. And I'm really excited about it. So that's first we're going to look at sort of what's going to go underneath and behind the racks and how the wiring is going to go in the places where it will not be seen. And then we're going to do some testing on the board itself and seeing how that works out. That's what we've got in mind. And I think when this episode is done, I'm going to feel a lot more confident and a lot more comfortable about where I am on the state of the studio. I'm not going to feel like I'm just spinning my wheels here, that sometime very soon live radio will be happening precisely where I'm standing instead of pre-recorded video. So let's get to it, eh?
Hey, I just recorded the intro for the next episode, and I think my hair is weird. Can you take a look and give me some advice? Here, I'll send you a screenshot.
Well, the right-hand side is definitely sticking out. I guess that you slept on that, and maybe I shouldn't have braided your hair yesterday. But to answer your question, I think that it is probably just fine to use.
Well, at some point I need to stop listening to talking heads and actually get to work. So what I have before here is another piece of OSB. So part of the reason the broadcast desk is as big as it is that it's designed to hide all of the wiring well away from people who shouldn't be playing with the wiring. It has built-in racks, and then plenty of space behind those racks for someone like me to crawl around in. So normally what happens is you affix a bunch of wiring bits to a board, and then affix the board to the inside of the desk. Basically, you screw things into the board, and then you screw the board into the desk. However, I don't want to screw the board into the desk. Like I said, I want to build this thing modularly so that it can be dismantled and put back together should the studio need to move. Hopefully the studio isn't moving anytime soon, but, design for what may occur. So this is the one that's going to go under the mixer, this board here, and then there's two others, one for each of the racks. So we've got basically 4 rack areas. We've got, 3 rack areas, really. We've got the processing stuff, which is the thing that sits on top of the desk. And then we've got the high power bits and the data bits. And that all sits under the, in the rack built into the desk. So this one goes under the board. This piece of OSB will be under the board, as you'll see later. And then I needed smaller chunks of wood for stuff that would go under, into the racks. And so what I'm using for that is leftover bits of the test piece of plywood that we used to plug the hole in the table. You can see the test route Sharon did here. This is by far the nicest piece of plywood I've ever used to do that, but whatever. It's what we have on hand, and I don't have much else I can do with it, so it's good for this job. So there we go. All right, so over here to the board, if you look on the back plane of the board, we've got these Molex connectors here. So this is the connector that connects here, I'll show you. So here's an N60, and it's got that edge connector, and it slots in there. And I counted, and yeah, it's exactly the same as an ISA board. So if I need to do something funny, I already know the specs of this thing. And then back here, there are these two wonky Molex connectors. One which is two for each channel, one which is for audio, the other which is for logic. So over here, we have these punch blocks that we recovered. One of these punch blocks handles two strips. One for audio, one for audio, one for logic. Or at least that's how it's... No. I can see that. Audio and logic on one punch board. And then here's the other end of it. So we're going to place these here on the top. Enough for the whole board. And then it's going to slot underneath here. And so if we lift up the meter bridge, you can see that there's a hole. All the wiring will go underneath here, slide under there, and then into there. And then on the effects rack here, the other boards will go back here, and on the power and data rack, they'll go in the back like that. So that's how that's going to work. So I'm going to lay that out. So, and then I've got these punch blocks, which are already configured for output. And they go here at the end. So basically all the 66 blocks at the top here, and then on the bottom on this side, we'll take two chunks of wood drop the patch panel in like that, and that will handle the ins and the outs and stuff like that. So in addition to all the balanced audio, there is actually some GPIO going on here. Each channel has up to 4 pins, 2 in and 2 out, for monitoring things, switching things remotely controlling things, turning on air lights, which is a feature of radio stations the world over. This one will not be an exception. And so there's a lot of wiring that would need to go between this and where the processing for that is done, either to a relay board or to some computer or something like that with a relay board connected to it. And I thought about it, and it's like, well, that's a lot of cabling to run elsewhere. And I'm a computer guy. Why don't I just make it digital, and make it digital as soon as possible? So I got an Arduino with, it's a Mega, so it has enough pins enough pins on it to actually get all the ins and outs from all of the strips here, and an Ethernet hat for it. So, Ethernet and SD card hat for it. So I'm going to watch the pins here and go directly from GPIO to Ethernet here and have it processed elsewhere. I'm a computer guy. I'm comfortable with Ethernet. Might as well do it that way. That way, for the on-air lights, I can use like an ESP8266 and have the signaling for turning the on-air, off-air lights happen over Wi-Fi, and I don't have to string wiring everywhere. My limitations are, for that sort of thing, are just wherever the Wi-Fi reaches. That's part of the reason why I kind of over-spec'd the Wi-Fi for this network. So that's kind of where it's going to go. So the way I was thinking about this was 66 blocks up here, patch panel here. Actually, what I might do is Arduino here, patch panel here, because that would make more sense. And then this space would be left over for documentation. Now, I've got some room in, so I'm going to try and space out the blocks so that if I have to install another one, it won't be too much of a pain. But I'm not using all of So there's 10 channels worth of blocks here, and I'm only going to have 9 channels in the mixer, and then including the output ones. And I'm certainly not using all 24 ports in the panel here. And if I need to, I can make a board and make more GPIO pins on the Arduino if that becomes necessary. So there's room for upgrades here. And then I've also got this space here, which I'm probably going to put like a piece of laminated, like a piece of paper that I laminate that has documentation on it and a place to do updates so that if somebody other than me has to approach this, they get some idea of what they're looking at. Otherwise, this is just more me working with power tools, although I did finally manage to liberate my impact driver, so that's good. Well enough. Let's see what the messages are. Where's my phone? Right next to me. That's hilarious. You're still attached. You should not be attached. Kind of undoes the usefulness of these when can't remove the punch block. Generally makes my life harder. Well, we've got. Does this make sense? Kind of does, doesn't it? Yeah, I think that might be the path forward. Oh, they are too long. Find a less efficient way to do that, Sam. I dare you. I installed these half of these upside down. I don't think it matters. I know what it's gonna do though. It's gonna drive me nuts. put it away. Why the hell did I put it away? The hell was I thinking? Clearly I'm not gonna need the clippers. I'm just zip tying 1,000 things. Alright, so this is basically it assembled minus the wiring. So this is all the work minus the work. I've got 5 punch down blocks for each punch down block works with two of the strips. These 2 punch down blocks deal with the output from the broadcast board. They go to an amplifier. They go to the encoder. They go out of here. I've got a place to mount the panel, the Cat 6 panel here. It's not screwed in yet, obviously, because I'm gonna want to set it down pretty much like this and wire to it. And I got this space left here for the Arduino. And the wiring to the Arduino, I'm not really certain how I'm going to do yet. And then all I have to do is just run the cabling, which I'm going to sit down and figure out how to do, and then take it from there. So unfortunately, the only screws I had available that were stout enough to mount the equipment were a little bit too long for the 7/8, for the 7/16 OSB. So there's little bits sticking on the back. I could saw them off, or I could just cover them with something. I might just hot glue them or something stupid like that, because hopefully this is going to sit back there and then not be touched by anyone ever. It only comes out when the wiring needs to be worked on. And I'm hoping the way I wired it out that there's enough cable to reach the underside of the proper parts of the underside of the backplane of the board, so that I can reuse this wiring that was handily done for me by the previous owner. So that's where we are with that.
So I've been doing a fair bit of reading on the board, but I hadn't actually tried it yet. Something might have been broken, so it was time to wire things up. And here I am soldering some connectors that I can connect to the punch-down block so I can hook it up to some gear. Nothing special here. There's a lot of good documentation. I have both hard copy and digital copy from the website, and some of it's pretty good. Like, you've got these pinouts here, which are great. Helped a lot. But you also have stuff like this flowchart, which is also helpful, but just a little bit terrifying, really. So to really get my mind around it, I had to basically make it go before I made it go. Probe the pins, that sort of thing. Figure out how it goes. Here I'm actually showing Becky how the punch-down block works. And so I figured out that the logic pins of this board are 5 volts, which makes tying it to an Arduino actually quite easy, which is good. Here I am starting to wire it in, and I'm testing continuity on things because the punch-down blocks are old. And actually, that was Becky actually punching things in. She took to it pretty quickly. That was pretty good. And here I am testing things out, and I'm not really happy with what I'm finding. Am I getting output? Yeah, but it's super noisy. So at the end of the night, I turn to Becky and I say,
well, I am passing audio through the board. I have one channel set up. And I have a microphone going in, and I have some audio coming out. It looks terrible.
But you have audio passing through the board.
I have audio passing through the board. You talk into the microphone, the meters move. Want to come look?
Mm-hmm. The meter moving, it is! It's the first and second one! And it's going! It's going pew, 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 do, 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 do! Look at that! I'm making the needle wiggle! Wiggle, 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 wiggle. That's so cool, Sam. Oh, you're filming!
I am.
I'm making the needle move. I'm probably peeking. Wiggle, 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 wiggle.
So here I am, figuring things out, looking at trim pots, and trying to figure out why the noise floor was so high on the recordings last night, on the output of the board last night. If you looked behind Becky when she was talking into the microphone, you might have seen the recording. It was just super noisy. It turned out I was plugged into the wrong thing, but the thing that I was plugged into was also supposed to be the control room output, which was also supposed to be fairly clean. Guess what I'm watching in the background? Anyway, so I haven't really solved that yet. I think it might be that funny-looking potentiometer on the second strip from the end there. But once I plugged it into the right outputs and cleaned some other stuff up, I got a really good output. It took some doing, though, and I also had to punch in another channel to make sure, I could just to test things out. Also documenting what I'm doing, and here I am scoping everything out. And I'll be honest with you, most of the time, I'm just trying to figure out how the interface on this scope works, because I haven't used it very much yet. This is really my first major use of it. But I got it going, so I was able to test out the pins and get everything figured out and get it sounding nice. And then...
So it's one thing to read through manuals and look at equipment and see how it might go together, and it's another thing entirely to actually put it together and make sure it works. And so what we have here is basically the studio in a microcosm. It's most of the chain, at least theoretically. So what we have here is, this is my tablet. It's connected to that sound interface. It's just playing an 800 hertz tone, and it's wired into this punch block, as is this microphone this microphone preamp, which is connected to this microphone. It's all wired into this punch block, which goes to these two input channels. And so this is the board, and I only have 2 channels installed on it right now. And then this is the output punch block, and the only thing wired to it is 2 XLR cables, which are going to the inputs of the digital mixer, which is currently recording over here. And then on the external monitor over here, I have the mixer going. So, if I queue up channel 2, you can hear in the Q speaker here that it's playing an 800 hertz tone. I can turn that off, but I crank up the headphones a little bit so maybe you can hear it in the headphones, I don't know. But if you look at the VUs, so yeah, we're playing a signal through it. And then the other thing is, I can turn on this other channel, crank it up, and then go over here to the microphone. And I can talk into the microphone, and you can see it working out here. And this is the first time I'm talking into I'm talking through the audio board. It's looking pretty good from here. So, yeah. Milestone reached. So I don't know if I've made it clear enough, but this was a big milestone for me. Making the board work answers a lot of questions for me. I've had this board for years, and I've never really had a chance to test it out until now. And this was the big question of the build-out was I going to figure out the board? Was it going to work? And so far, so good. And so what remains is just doing the implementation. I can move a little bit faster now. I have a clearer idea of what goes on, and the board works. And so this was a bigger deal than it might seem. Anyway, the list of people you see before you are my patrons. I'd like to thank them for helping me make this channel and all the stuff I do go. If you would like to be a patron, you can join my Patreon. There's a link down in the description. I hope the patrons are enjoying the direction things are going in. I'm going to be doing a bit of soldering in the next couple of weeks, so I'm going to be asking my patrons for some questions or things they'd like to hear me talk about while I'm working. See you next time. I keep wanting to go hit it over there, when I can just as easily boop